The figure above shows a regular hexagon with sides of length A and a square with sides of length A. If the area of the hexagon is 384 and square root of 3 square inches, what is the area in square inches of the square? This is not an easy problem, but it's the one that we can solve if we have certain understanding of geometric properties and enough patience and confidence to go step by step. We're offered a hexagon and a square, and hexagon has the sides at the length of A, and this is also the case for the square. And one other piece of information that we're provided is that the area of hexagon is 384 and square root of 3. And with this information, we need to attack this problem and try to solve it. We're offered area only for the hexagon. So if we think about hexagon, this is not one of the simpler geometric objects that we have. The simpler ones, the ones that are normally discussed, are those of triangle, square, and the circle. So it's fair to assume that the knowledge that the SAT tests probably has to do with our understanding of one of the basic objects. And upon looking at the hexagon, it might become pretty clear that hexagon consists of triangles, one a simpler object and a familiar one. We can see how we can form 6 of those. So let's zero in and take a look at one of them and draw it up by connecting the corners of the hexagon to the center. If we're looking at the triangle, we can make use of the area that is offered for the hexagon, and it would be exactly 1/6 of the total area of hexagon. And the reason is that the hexagon consists of exactly 6 triangles of the same triangles, or as they're called, congruent. And so being 1/6 of the hexagon, the area of our triangle is 1/6 of 384 and square root of 3. Let's pull out our triangle and look at it closer. So let's also think of what the area of a triangle is, and we should know that it equals to 1/2 times base times height. So the base is the lower part of our triangle, and let's create the height by dropping from the top corner into the middle of the lower line. We just created 2 right triangles, and let's focus on one of them. Since the base equals to A as defined in the problem, it says that the side of the hexagon equals to A. Then the right triangles, one of the legs, the one at the bottom, should equal to A over 2, or 1/2 of A. It may be dispiriting to have so little information about the triangle, so let's get creative. Since we do know that there should be enough information, let's look at the hexagon one more time. What we might notice is that our triangle's top corner should equal to 60 degrees. And the reason it is so is that the full circle at the center of the hexagon is 360 degrees, because as we know, the full circle is 360 degrees. And since our triangle is 1/6 of the hexagon, it means that our angle at the triangle should equal to 60. We used our main triangle to create 2 right triangles, and as a result, the top angle of the right triangle is 30 degrees each. Since we're focusing on the left-hand side triangle, which equals actually to the right-hand side triangle, We now may notice that we're dealing with one of the special right triangles. And there are two special right triangles, the one with 30 and 60 degrees in addition to the right angle, and the one with 45 degrees each. Both of these triangles and their characteristics are put at the front of the section on the page where this section directions are provided. So the test takers make it available for you to consult. Let's take advantage of this and take a look at the right triangle with the degrees of 30 and 60. What we can see is that this triangle has certain proportion in the length of the sides. And as far as we're concerned, since we know one of the sides to be a over 2, and this is the side that is lying across the 30-degree angle, we should be able to find the other leg, what is height in our triangle. And since it equals to the shorter leg times square root of 3, you can see that in the form that we're provided, it says that the short side is x and the longer side or the longer leg is x square root of 3, which means it is the length of the shorter leg times square root of 3. This way, we can derive that our height should equal a over 2, which represents x in the form that we're given, times square root of 3. Okay, so now we have everything we need for the area of triangle, because what we need is to know the base and to know the height. We know that the base is a, as provided in the problem, and the height, as we just calculated, equals to a over 2 times square root of 3. So let's plug it in and set it up. So our area of the triangle equals to 1/2 times a over 2 times square root of 3. And a over 2 times square root of 3 represents height, a represents base, and 1/2 is part of the formula for area. What we also know is that all of this should equal to 1/6 of the area of the hexagon. And we're given the area of hexagon at 384 times square root of 3. So let's divide that by 6. And with a lot of numbers and one variable, a, or the unknown in this case, we can probably find a through mathematical manipulation. Let's work the left side of the equation and leave 1/2 times a as it is. And now let's break down a over 2 into 1/2 times a, because it is the equivalent of a over 2. And the reason we want to do this is that we want to isolate the unknown a so we can calculate it and find what it equals to. And then we could use this length a to calculate the area of the square, which is what the problem asks us to do. So let's continue. What we get as a result is 1/2 times a times 1/2 times a and times square root of 3, the remaining part. And on the right hand side, let's perform the division. 384 times square root of 3 divided by 6. What we get is 384 divided by 6 would be 64. And then we have times square root of 3 left. And as we move on, 1/2 times 1/2 equals 1/4. A times a equals a squared. And then we have square root of 3 on the left-hand side. And we have 64 square root of 3 on the right-hand side. The square root of 3 on both right and left-hand side makes the calculations a bit tricky. So let's just divide both sides by square root of 3. As we know, that we can do that as long as we do it to both sides of the equation. And by doing so, we will eliminate square root of 3 from both sides of the equation. And what we're left with is 1/4 times a squared equals 64. At this point, to isolate a squared, we need to reverse the impact of 1/4. And the best way to do it is to multiply it by 4, because once 1/4 is multiplied by 4, we get 1. And 1 times a squared is a squared. And that equals 64 times 4, because the operation of multiplying by 4 should be repeated on both sides of the equal sign. And as a result, we get a squared equals 256. Taking square root from both left and right-hand side, we get to our desired unknown a. And it equals square root of 256, or 16. We've done all the hard work, and knowing that a equals 16, we can now find the area of the square. If you remember, area of the square equals the square of its length of the side. In this case, the length of the side is 16. So square of that would equal 256. And this is the area of the square and the correct answer. Alternatively, we can consult the front page of the section where we're offered the formula of a rectangle, and the rectangle's area equals to length times width. Since length and width is the same for the square, multiplying the two, we get exactly the same outcome, 16 times 16, or 256. One final note, this is one of the more difficult questions that you can face at the SAT. SAT wants to see how you can find such multi-step problems and how you can deal with these. And that means that patience, confidence, and knowledge of the basics can get you very far. But if you're not patient enough, you may quit too soon. But sticking with it may lead you to the desired answer. So depending on where on the scoring scale you are, if every point matters and you're trying to get to the higher end of the score, you should not be intimidated by this kind of problems. On some of the easier problems, you should be able to save enough time to take your time and solve more difficult problems, so that it would take you, instead of maybe an average of 1.5 minutes to 2 minutes, if it takes you 3 or 4 minutes, it is by design. It's not supposed to be as fast, but the savings accumulated over the earlier section should pay off, and don't feel like you're doing something wrong if it takes you longer than solving the simpler problems.